This video, we're going to prove, let's give this a name first of all. If we're going to have this set being our basis for V, then as long as C is not 0, this is also our basis for V. Now, to show that this is the basis for V, I need to show two things. I need to show that it spans V and it's a linearly independent set. Now, let's check for linearly independent. Let's look at C1, cv1 plus c2, v2, all the way down to cnvn equals 0. Now, a property of vectors and scalars is this is c1c times v1 plus c2 v2 all the way down to cnvn. But you know what? This is a linear combination of just the vectors in S. That implies that c1c, the first coefficient, or the first scalar, equals the second scalar, all the way down to equaling the n scalar, which is 0. That implies that whatever set we started off with, namely the set of these n vectors, that implies that the set of vectors C1, cv1, v2, up to v sub n is linearly independent. So that's half. Now I need to show that it spans. Okay, so let little v be in V. Since S is a basis for V, then the span of S is V. Then the span of S is V. I just need to show that the span of S prime is also V. Okay. So there exists C1, C2, all the way up to Cn, such that little v is C1 V1 plus C2 V2 all the way up to Cn Vn. That is, V was able to be written as a linear combination of the vectors in S. But I want it to be from the vectors of S prime. Well, since C is not 0, I can divide C1 by C and then multiply by C. That is, I'm going to use that as the first vector, cv1, plus c2 times the second vector, all the way down to cnvn. That is, I was able to write V as a linear combination of those vectors, cv1, cv2, up to cvn. So S prime spans V. The span of S prime equals V. Putting these two together, we have that this set S prime, combining S prime, is a basis for V by definition. That constant doesn't do anything. In fact, we can put constants in front of all of them, or more than one, but not all. This completes this proof. If If you like theorems like this being proved, subscribe to my channel. That's all we do on this channel. Tell your family and friends about it. Subscribe to my channel. It's a great channel to be a part of. As always, continue to watch and learn.